to the state 4 to 5, which is in a boiler. So in a boiler here, we can see that P4 is equal to P5. And given here, T5 is equal to 1800 Kelvin. Okay, state 5 to 6 is in a turbine. Again, in a turbine, since this is an isentropic expansion, we can use formula hijau. Then the formula here, P5 over P6 to the power of K minus 1 over K. The problem is here. Okay, P5 over P6 is not the same as P3 over P2 or it's not the same as here. Okay, P4 over P3 or P2 over P1 is equal to 6, because this pressure ratio of 6 represent in compressor 1 and compressor 2. Okay, so here we want to find P5 over P6. How to find P5 over P6? Okay, so this is how to find P5 over P6. The idea is we take out P5 over P6 here, and we know that P5 is equal to P4. Then we write down P5 is equal to P4, and also P6 is equal to P1. P6 is equal to P1. Then I modify this equation, P4 over P1. Okay, I modify it with P4 over P3 multiply with P3 over P1. I know that P4 over P3 is 6. Okay, and P3 over P1 is also P3 is equal to P2. Here, if I refer here, P3 is equal to P2. Okay, then P2 over P1 is equal to 6. Right? Here, P2 over P1 is equal to 6. Therefore, I will get this. And then P4 over P1 is 6 multiplied with 6 is 36, and P4 over P1 is also equal to P5 over P6. Then I put all the value here, and I find that T6S is equal to 646.6 Kelvin. Okay, this is for T4S. To find this is T6S, not T4S, sorry. Okay, so to find T6A, then I will use isentropic efficiency of turbine formula, which is WA over WS. Okay, here T5 minus T6A over T5 minus T6S. Then I will get T6A as a 819.61 Kelvin, knowing that the isentropic efficiency of the turbine is 85% or 0.85. Then I go to state 6 to 7, which is in regenerator. Okay, T6A is equal to T7S. Okay, and I use the effectiveness equation to find T7A. Okay, Q regen for actual over Q regen for maximum. So here, if I refer to TS diagram, Q regen is T7 minus T4, and maximum is T7S minus T4. Okay, here. Yeah. For actual, T7A minus T4A over maximum T7S minus T4A. Then given effectiveness as a 0.7, then I will get T7A as 782.98 Kelvin. So settle for question number 1. Then we go to question number 2 to find M dot. Okay, to find m dot, given here W dot net is equal to 30 megawatt. So this is the formula of W dot net. W dot net is equal to m dot multiply with W net. W net given here is WT minus WC, and this is the formula for WT, CP, T5 minus T6A. I get this value. And WC, we have two compressor here. So please take these two compressor into account. For C1, CP, T2, A minus T1. And for compressor 2, CP, T4A minus T3. Okay, so I will get WC as a 617.025 kilojoule per kg. Then rearrange this formula. M dot is equal to W dot net over W net. Then I will get M dot as 80.587 kilogram per second. Please don't forget to put the unit. Next question is to find backwork ratio. Backwork ratio is the ratio between work of compressor divided with work of turbine. So I get 0.6222, which means 62.22% of work of turbine is used to drive the compressor. Lastly, thermal efficiency for this cycle, W net over Q in, and Q in here, okay, Q in is CP T5 minus T7A. Please don't get confused between Q regeneration and Q in. Q in is here, T5 minus T7A. Okay, then I get the thermal efficiency as 36.78%. So I hope you understand the example of the Brayton cycle with intercooling. Thank you.